for you? Do you think prompt engineering might die out in the future?
I don't think it's going to die, and it's a strong statement, and I'll tell you why. It's
Oh,
controversial, but let me tell you this: reading less is important if you want to do great in
do you
research.
still recommend, like, if a young PhD student comes to you and asks Swaroop, like, I want to work on LLMs, tell me where do I start? What kind of advices you would give to that person?
Great question. This is my favorite question. I'm glad you asked me this question.
All right. So, hello and welcome everyone. Today on the podcast, I have with me Swaroop Mishra. Swaroop is a research scientist at Google-Deepmind working on BARD, or which now most of us know as Gemini. His research expertise includes instruction tuning and different prompt engineering techniques to improve reasoning and generalization performance in large language models that can also tackle induced biases in training. Before joining DeepMind, Swaroop graduated from Arizona State University with his research focused on developing methods that allow models to learn new tasks from instructions. Swaroop has also interned at a bunch of places, including Microsoft, Allen AI, and Google, and his research has been very influential in the recent developments of large language models. So, Swaroop, welcome to the podcast.
Thank you, Jaya, for the introduction and for inviting me.
So, before we get started, like, what was your entry point in AI? Like, what was the landscape when you entered AI, and what was that thing that stick into your head that this is what interests me in AI, and I want to pursue a long career in research?
So this is back in 2015, 2016. So I'm from originally from electrical background, as like control system engineering and those kind of stuff. But I was taking a neural course back in IIT Kanpur, and there I got to know that this black box modeling is pretty popular and pretty powerful to model any kind of phenomena. And and then starting with very small, simple algorithm, how can we scale up and get the true potential to model different physical phenomena and solve some really challenging problems. So I think that is the starting point. I started to feel that this can be really powerful. And then, of course, the 2017 the transformer paper sort of really influenced me, changed my mind to really go deep into language model, which is LLM now, the NLP area. But yeah, that was the starting point.
So, one of your research works that has been very much in the limelight recently is based on instruction tuning, right? And it came out, I think, if I'm like, correct me if I'm wrong, but it came out in 2022. But I believe you have been working on since on that particular idea for a long time before large language models was this much in the talk. So, how did that idea came out? So, like you said, like you're from electrical engineering, so how did that particular transition happen, going from that particular background all the way to specific field in NLP, which was the term used back then, and how did that idea come on across that instruction tuning might be something useful in the future?
Yeah, great question. First of all, that paper came in 2021 April, but the proceeding it got published in Asia, took some time and came in 2022.
Mm,
So the idea is like this, when in typical machine learning, we train on some task and we test on some task, right? That means the models can do only the task it is trained on, right? And that's actually a big blocker to adopt machine learning system in real world application, because in real world people can ask any kind of questions, right? I mean, that can go well beyond on which it is trained on. And people, the end user, do not have time or even the knowledge or expertise to train the model, collect data, fix hyperparameters, tune, and even wait for the model to get trained to answer. So we actually want everything very quickly, right? So what the user want ultimately is they can just express a task in natural language or just give an instruction without requiring to get a lot of examples, and model learn directly from it, you know. So that's more like a product driven idea, that this we if we want to create this LLM revolution, we need the model to be able to do task, and it is not trained on. And one way to do that is express the task in natural language and learn from it. So that was, I basically worked in industry before starting my PhD for a few years. So I had that actually helped in bringing the real world angle to research. I mean, in academia, often we need that kind of outsider um, industry perspective to know what are the right problems to work on. And this was the one of the early motivation, that if we can enable such capability, that would be really good. I mean, actually, if you see right now, Gemini, ChatGPT, and all these models, you just directly talk. You directly ask a question and it answers it, right? You don't train it, right? And you
Right.
can ask any random question, right? It does pretty well. But so that was the capability. That was more interest. That this is what we want to build. Now the next question is, okay, if you want to have that capability, what can we do to get this capability out of the model? And that's where instruction tuning come from. Is basically it's a training method, right? When we train, typically previously we just used to use the examples, right? Like input example and input and output pair in traditional machine learning. But instruction tuning said, wait, we care about instruction at test time, right? Like user is going to give instruction at test time. Then should not the test training be more similar to testing for the model to learn it better? And
Right.
that's where we introduce this concept of instruction. And these instructions are like basically, you can think of like some task specific knowledge, right? That actually explains the task. So for example, right, say if a human, right, learns a game, f- mm, it just doesn't learn a game by watching somebody. It also listens to a friend's narrative or a commentary or reads about it, and that knowledge helps the person to learn a game very quickly, just by looking at one or two examples, right? We have seen that. We have played many local sport in back in India, right?
Right.
And we didn't need to learn by a lot of examples. We learned it very quickly because one of our friend told us that, okay, oh, this is similar to cricket but slightly different, and also this has similarity with football. And we see one or two person play and just learn it, right? That is like very very inspiring to me. That I mean, as you know, many of the scientific breakthroughs in the world inspired by observing some processes or um, more rigorously. So this is one of the early motivation. I told you at the beginning what's the goal, and now I'm telling how we achieve it, inspired by how humans learn. And that's why we introduced this instruction in training. And then we saw that, if we do that, model learns very quickly. The generalization to unseen task at test time improves drastically. And yeah, that was like some of the early stories. Yeah.
I see. So, what is the so normally we understand this concept that yes, once the model is trained on an X number of data set, it performs really well in that particular distribution. But when it goes out of that, it fails very drastically. Now you are suggesting that maybe I give it some amount of instructions that I might know that happen at test time. But what is the guarantee that if even at the instruction, so let's say it was trained on n number of instructions, but when it comes to an unseen instruction that was not present in those n set, then what is the guarantee or what is the intuition that model is also able to generalize beyond those instructions that it was already fine tuned on? So why what is the guarantee? Why does the model would
Yeah.
perform well
Yeah.
on that?
Great question. So see again, um, so the idea is these are pre-trained models, right? We do this as on the fine-tuning phase, right? Instruction tuning is one way of doing fine-tuning, right? So pre-trained model has some knowledge about the language. It can understand language. It has been trained to understand language. So what happens is, previously when you're doing machine learning, directly learning from examples, it is model has to rely entirely on the example to learn the similarity and difference between different tasks. So I'm talking about multitask learning, right? These days everything is multitask learning, but now by adding that extra information in the form of knowledge, in the form of instruction, a model knows the similarity and difference between tasks pretty well, and it can leverage its pre-training knowledge to learn the task better.
Mm,
Now, at test time, of course, the instruction is going to be different, right? It's going to be from different distribution, but model can do composition pretty easily, like composing over. I'll give an analogy to make you understand this better, right? Say, imagine you are like say learning sport just by looking at example, and you are learning by just observing people play, and then you also very different, like say watching a Japanese game and you're observing from it and you're playing, you're understanding it, and you are doing that for like say 100 such games, right? So you can learn, but you'll have some biases implicitly
right.
that may lead you to, if you watch a new Japanese game or a new Korean game, you might have some difficulty learning it. But imagine while also you are watching the game, I'm also telling you, I'm giving a commentary about the game, saying what this game is about, and then that means using your own knowledge. Basically, you can better understand the game, and when you being shown a new game, you can learn it better, and that's because and that's similar to the pre-trained language model. Pre-trained language model has some knowledge. Now, at training time, when you express the task with instruction, it learns the task better, learns the intricate features better, so that at test time, you know, it can do some kind of composition, right? Maybe this is a combination of A plus B plus C, something like that, and
Right.
that learns to, you know, help you better. And regarding the guarantee, you see the performance, right? The recent performance improvement across tasks using this large language models actually is heavily powered by instruction tuning, and of course RLHF. So yeah.
I see. So maybe you have mentioned this in your paper that maybe I missed. So let's say if there is a sufficient amount of data set for a particular set of instructions. So let's say we stick with that analogy of learning sports, right? Let's say you have the data set of commentary and the data set is used enough. Would it be better if I use a pre-trained model and use instruction tuning to fine-tune the model, or versus if I just train a model from scratch on the data set that I want it to perform well on, which is the sports data set? Which of these two models will perform the best in your understanding?
Yeah. So see the premise between instruction tuning is models should have enough um, enough knowledge to understand text well, because then it can learn from instruction, right? And
Mm,
pre-training is one of such capability which is highly successful in providing that knowledge. That's why we do that, and it's very general, right?
I
Um,
see.
and we care about that because our we want our model to do a lot of things, not just one task, right? So that is
Mm,
one point. That's why we want pre-training. But having said that, if you can ensure that your base model is decent at understanding the type of text you care about, you can go ahead with that. But again, the generalization is a problem because your model can do well on the type of task it is trained on, but it's not
right.
broad enough. But pre-training gives that broad capability that even during commentary, somebody asks and something unexpected, world can still understand and learn from instruction. That's why we do pre-training, start with the pre-trained model.
I see. And broadly, in terms of when we talk about large language models, there is often like there are many terminologies that have come up. What one of them is basically instruction tuning versus prompt engineering. So can you debunk between these two terminologies? Like, what do these mean? Is there an overlap, or they are completely separate? What does prompt engineering mean versus what does instruction tuning mean?
Hmm. So, um, so prompt engineering is an inference time method, right? So it's like a kid, say the kid is not able to understand the question and do the task, right? So what you do, you often try to rephrase the question, saying that, oh, this is not hard. You actually read it, we do that, right? We tell that this may look hard to you, but this is actually asking this question, and which you might have seen in your textbook, in your standard 3, standard 4, like, and by simplifying it, often we get elicit the answer from the kid what it is
Mm.
trying to say, right? This is exactly what is prompt engineering. So basically, like you say, we prompt the kid to give you an answer, and similarly, we prompt a language model so we know what the model can do to some extent based on its pre-training and instruction tuning, and we can paraphrase the task. I can give you a simple example, right? A very simple, very early example is you can ask, where was this person born? That's a question answering task, right? If you want to use a pre-trained language model, this might be slightly difficult for the model. But if you say, this person was born in dash, if you convert this question answering task to a fill in the blank task, it suddenly becomes easier for the model. You know
I
why?
see.
Because it aligns with the pre-training objective function. It's the next word prediction, right? So that becomes easier because it is aligns well with the strength of the model. Just like I told you, if you want to make a kid answer a question, you ask a question that is similar to what it has learned in his class or textbook. It becomes easier. Now, that's a very simple definition of prompt engineering. Um, now, but the thing is, it actually also adds an overhead on the user, that you need to smartly phrase the question
Right.
for the model to learn and respond well, which is not very user friendly. We need people to have some understanding of the prompt, and that's why instruction tuning is complementary. The goal of instruction tuning is models should be able to learn from the free form instruction. Models should be able to directly do the task. So models would align rather than we align. So prompt engineering, we align to get the
Right.
best out of the model, but instruction tuning is for the model to align to our language, the way we talk. But it's a trade-off, right? Like, it's expensive. Instruction tuning is expensive because you have to backpropagate and update model parameters. So that takes some time and some resources. It's a training method, so not everybody needs to do that. And prompt engineering, even though it requires a little bit of effort, there are techniques to automate it. And so for light modification, models behavior, we can do a mini task. So many people prefer to do that prompt engineering because there are two reasons. First of all, like, if you want to use this APIs like Gemini API or GPT-4 API, you might not have access to train the model to backpropagate the weights.
Right.
So people prefer to use as an API as a service, and then they just change the prompt. They operate in that level. That's why it's pretty popular. You see many application, many business being built on top of that. But people who wants to fine tune their own model, or even the teams which are building the models like Gemini, GPT, and all, we actually spend a lot of effort in aligning to users' preference, so that next time you don't have to do prompt engineering. So
Mm.
ideally, in an ideal world, if instruction tuning is done perfectly, you don't need prompt engineering.
I
Um,
see.
yeah. So basically, if you are building a business and you know what kind of queries you care about, um, if you can create a data set, and if you do instruction tuning really well, you don't need prompt engineering.
Okay. And one of the fundamental concerns that a lot of people have raised related to the idea of prompt engineering is that it will inject some biases. So whenever I'm trying to make a prompt, it will create a bias in what is being retrieved by this particular model or what is being generated by that particular model. So what do you have to say on that? Because let's say if the model comes up with an answer to one of my questions, and I say it, can you make it more XYZ? Like I am trying to make it in a certain way, but it might deviate away from the actual fact of the first question that I was asking. So I'm trying to manipulate the answers that the model is generating, and it's deviating away just in order to align with whatever I'm trying to ask next. So first of all, do you think it will create biases in the model? Like, does prompt engineering induce biases? And secondly, if that is wrong, why is that the case?
Yeah, again, very good question. Um, See, prompt engineering is sort of again, I said, like, it's sort of a knife. If you know how to use it, great. But if you don't know, like any other technical method, right?
Sure.
Um, I don't, I don't say it's a bias or something. It's alignment, you know, in the sense, So, I mean, think of this as a small kid, right? They give an answer. You often ask them that, oh no, you just have to give it in bullet list, or you have to express in a different language, or you have to give it summarize or make a story. So in that process, they also often lose some context, right?
Mm,
Um, that also happens, right? But instead of blaming the kid, I'll probably blame my instruction, right? That
right.
probably my instructions were not detailed enough to cover different edge cases, or it was specific, too specific for the model to deviate. Because we know these language models that what they can do. So I always think them as little kids that they can do something. So it's our responsibility to, how can we get the best out of them.
Fair enough.
So
Mm.
from that point of view, writing a good prompt is actually or a good instruction is actually a pretty much a skill. There are many, prompt engineering courses, and people do, lots of prompt engineering every day. There's some prompt engineering positions also in the job market. So yeah, that's actually pretty much how to write an effective prompt without letting the model deviate from its original content. Is a skill. It's more an art we need to learn.
So, but then maybe a follow up on that, like maybe a hard question is, you said like prompt engineering might be automated at some point, right? So you said like if instruction tuning gets better and people like you have are working on that at Google. So do you think that, and on top of that, you said like there are a bunch of courses, a lot of people, and I think a lot of products that do prompt engineering for you. Do you think prompt engineering might die out in the future if large language models are here to stay? Prompt engineering might become redundant. Maybe
Mm.
models already do that, or maybe there are tools that can just do that. You don't have to do it, or there won't be any intervention from humans necessary to do the prompt engineering part.
I don't think it's going to die, and it's a strong statement, and I'll tell you why.
Okay.
Um, See, so prompt engineering is always the next level of what the model can do. So, for example, basically, um, it's like you're interrogating. Again, I'd like to give an analogy to explain in simple language before I
Yeah.
go deeper.
Yeah.
So you can train a kid well enough to do JE, say for example, it's like this was the quota factories, that files are still there, and say other competitive exams, but and that you can do instruction tuning. You can tune the model, tune the kid well to do well in the exam. But prompt engineering is more like an interrogation or an investigation to find out what the model can truly do. Maybe the kid, who has already done well in JE exam and different exam, can do something even more powerful, right? That we don't know. And prompt engineering in one way to elicit that, because it's sort of like proving the model, right? So it can be used both in positive and negative ways. So positive ways is to find out different strength of the model. Maybe the kid has learned so much by preparing for JE that now it can solve a really tough Olympiad question, or even a unsolved problem in mathematics. And if we prompt it really well, maybe that knowledge can give it to that. That is like the power in a positive way, right? In a negative way is people often use that to see if the kid has really learned the basics, or have just crammed some patterns to do well on the exam. And that we often do in interview, right? We ask
Right.
follow-up question, we ask very detailed question to find out some fault, even say in Newton laws, or the optics, or any of these basic things. you know and the analogy in the LLM world is people using instruction tune model to do wonders, like say in generating, you see this automatic automatic LLM calls, right? Doing a lot of tasks,
Right.
creating a GitHub repo, people building companies end to end by just using prompt engineering, by calling the model a lot of times, just to see, those kind of tasks are not in our eval, right? But by using prompt engineering, people are actually able to see what the models can really do and its true potential. That's positive way. And other people also use it to solve really complex problem. You saw different demos recently popular. But the negative way is, jailbreaking, or finding out what the model truly believe. So sometime like, and even for privacy and security and those kind of thing. So for example, some people use it to see if it can identify somebody's credit card information, or or if it is can tell us its own weight, or how it is trained on, because they're proprietary models. They're not supposed to tell this, right? Or some finding some easy way to break the model. So that's why I said model become instruction tuning. uh, so like I said, like depending on your goal, if you care about a specific use case, instruction tuning can help you get rid of prompt engineering completely. But prompt engineering will be still there for people to explore what's the next level thing. So tomorrow, if say our model solve a really challenging problem, prompt engineering will be also there to see what it can do beyond that, or whether it has learned things clearly, correctly, or there is some problem. So it's more like a proving. It's more like a tool that is there, that needs to be there, and it's healthy to be there to show what we would need to do next in research.
Right. So I think, yeah, like the way you said it, and maybe if I can rephrase it, is that instruction tuning is really necessary in the phase where you are training the model, or pre-training the model in the phase where it is not released yet. But when it becomes open to public, let's say for research or for product utilization, then prompt engineering will be the first step that people will use to interrogate what exactly the model is doing, if it is doing correctly what it is said to be doing, and what it has been trained to do. So yeah, like
Yeah,
maybe the prompt engineering techniques might evolve over the time, but like the concept of what we are trying to do will stay in some way or the other.
yeah. It is definitely going to evolve, and it has already evolved. If you see, um, when we back in 2021, like when we work on this instruction tuning work and some early prompt engineering work, reframing and those kind of work, the prompts used to be pretty small, and it's almost like a very slight modification of the natural language instruction. But these days, if you see, the prompts are pretty big. It's like long with detailed, different style. People often use some kind of encryption also to extract text. So it has evolved already, become longer, become encrypted, language is different, and it's going to keep evolving further. Yeah.
Um, okay, jumping back to one of the topics that we discussed in instruction tuning dataset, what are the factors that you think should be considered when we focus on quality checks for these instruction datasets that we can fine tune the model on? What are the factors researchers should consider for checking the quality of that?
Yeah. So again, that's a very great question. Actually, this kind of data quality checks are often emphasized, um, but it's like one of the real propellers of large language models. Um, so regarding the question, what kind of properties you look for? First thing is response quality, like the prompt diversity and response quality. These are the two factors that matters the most. By saying prompt diversity, you want to have enough coverage, right? Say you are a business and you have like 10 different use case across products. So you want to ensure that the prompts are well covered in your training data. And so that means the challenge is, what exactly is prompt diversity? How do you measure it, right? And how much repetition to keep, right? Say maybe your customers care a lot about writing emails, right? So I might focus more on having email prompts. But then what kind of email prompts, how to diversify? That's are some open challenges. And how much, like if you cluster, so like email is one use case, story is other use case, poem is other use case. How do you ensure that the clusters are well balanced, or where to how much the cluster difference should be, and those kind of thing. So that is one critical factor, that how much coverage you had. And specifically when we build this kind of like large language models, like Gemini, ChatGPT, and all these open models, I mean, it's not for one use case, right? It's for a range of use case, and people can ask any kind of question, right? So there, it's basically almost impossible to know the use cases and over have clusters around that. So there, how do you expect or anticipate the future use cases and design prompts? That is becomes crucial. The other one, which is equally important, probably even more important, is response quality, right?
Mm.
So it's response quality. Say, in traditionally in our NLP research or even machine learning, we have an input-output system, and often the output is like, so if I give a math question, the output can be just an answer, right? But do you think a user will like if given a question and an answer, a short answer, like they don't like it, right? They want to see a detailed step-by-step solution, right? So you
Right.
have to get the responses aligned well with the user requirement. But I'll tell you a contrary use case in development, right? Sometimes you don't want detailed answer. You want an exact answer because you have script to parse it. You get your answer in JSON format, a specific field, because that's what the model is going to understand. And so it depends on use case, and that's how the instruction you give basically, and based on that, the response should be different. So response quality is important to align
Right.
well with the user needs. And very important is how do you diversify it, you know say for example, if you keep a lot of like long lengthy responses, the training data, when model will think that okay, I should always generate some garbage, to do well, to minimize the loss, right? And that means next time you ask an instruction, generate an answer in one word, it will still give you a paragraph. It's like it's not helpful, right? So that also introduces biases. Like you need to diversify well enough so that model really follows instructions well and do not always generate long responses. So that should be balanced across the task. And of course noise, right? Because what happens is, see, um, people um, definitely use some kind of um, synthetic data creation a process as soon as they the naturally existing data gets over, right? And in that process, or even in naturally created data or human generated data, humans also can do mistakes, right? But that noise sometimes gets amplified because if you tell the model something, if you reward the model for something bad, right,
Right.
especially during instruction tuning phase, it's just going to amplify. Like if somehow you leaked that 2 plus 3 equal to 4, something like that, something, it's going to haunt. So
Right.
making sure the data is clean, both in human annotated data by rigorous data quality checks, and actually even more in synthetic data. um, like how can you ensure the quality is good? So that's actually a very critical factor.
Right. And is it fair to say that it's more critical to maintain the quality of data in the fine tuning or the instruction tuning data set than even the exact, like the pre-training phase? Because, like you said, like the model is very sensitive in the instruction tuning stage to generate anything that's not correct. Like you said, 2 plus 2 equals to 3. Like the model is more sensitive to learn wrong biases. So, like the quality check part is much more important in this instruction tuning phase.
Yeah, it's important in both phases. Like it's
I
important
see.
in pre-training and instruction tuning, but instruction tuning probably amplify more
I see.
than in pre-training. So you have to be more extra careful because pre-training is large scale, right? And it's also unsupervised. So, you know, but this is more supervised, right?
Right.
And
Right.
anyway, I mean, you can always control. So SFT, this instruction tuning is more for controlling model behavior and aligning to what we want, user needs. So that's we have to be extra careful because the biases and this if there is any noise, it's going to be amplified really big. Um, yeah.
And one of the questions that I like, it's much more like an overview question. So we have seen like most of these models, Gemini, ChatGPT, these kind of models are particularly great for making chatbots. So yes, we can interact with these people in a best way. It has become really good. So now it can follow instructions. It can also, like you said, like it can understand prompts. It can generate, retrieve results. What do you think is the future case use case of LLMs? Like we keep on hearing more about decomposition, agents, and those kind of things. Like, what do you think of those things? What is the next stage people are using this hugely huge models of data sets, trained models to use it for. So apart from being just a chat tool that can serve humans for their queries, what is the next phase?
Um, there are many ways this LLMs can evolve and want to evolve. You know, you mentioned chatbots. We had this paper recently. It's called Beyond Chatbot. What are the things model can do beyond chat? So agent is one really exciting area, you know, because the problem with, I mean, chat is great, right? Chat has brought us this far. In couple of years back, you know, LLMs, I think it was limited to researchers, but now, you know, if I go ask my, you know, nephew or, you know, a small kid in the house, they're like, oh, we use ChatGPT in school, you know,
Yeah.
or like use Gemini to generate interesting content, you know. It's getting very popular, so it has definitely brought us this far. So we should acknowledge that. But having said this, chat has its own problems in the sense that, you know, for the chatbot to give you accurate response, you need to know what to ask, right?
Right.
But many times people don't know what to ask, right?
Right.
What about that, right? And, you know, and sometimes if you ask this model a very specific question, it gives you a generic response. Say, for example, what project should I work on? Or like, say, I want to make a trip to, you know, Washington, D.C., and where should I visit? And I want to make a special plan depending on my preference, right? Like a personalized plan. But model gives some generic answer probably, which is not ideal because I may not like museums. I may like something else, right? And I might prefer a different mode of transportation, what the popular ones than the popular ones, right? So those so aligning so basically when we build language models as chatbots, we align to general user preference, like the common people, what people do. But it may not align well with specific personalized goals, right? And that's where agents come into picture. You know, it's we as humans. I trust my travel planning person to help me plan, right? We help humans. We actually trust humans because they are like they listen to us and they give a personalized plan for us, right? We go to a doctor, and that's what the reason. So that's why I think the future is definitely one of the interesting application is agents, personalized AI, and that what that does is think of as a clone, right? You take these language models, LLMs, and you make a clone of it, and you train that clone or tune the clone to your preferences. Say like
I
you
see.
like to fly United Airlines, you like to stay in a Airbnb rather than a hotel. Like you don't have to tell it, right? It learns it, it memorizes it, just like your personal assistant or one of your friend that knows you better, and then do task reliably on your behalf, which you can really trust. Like an agent, which can go and book the flight ticket for you, um, access to your credit card details, but you can trust that it's not going to be leaked. So that's where, and because um, like I said, the person don't have to talk every time. Oh no, book me United Airlines flight, or take this or take that. It memorizes it from your previous experience, and it makes a custom plan for you, and it still asks you the right question, right? you know because it knows that you like Airbnb, but it still asks you, okay, there are three options. Which one you like? And then, I mean, the communication mode, is as first of all become slightly narrowed, and that actually helps because people have lots of work. They are not
Right.
free to chat, and sometimes this chatbots gets difficult to control because it still gives generating, generic content. So that's where the agents are going to come, and that's going to be the really, boost up the adoption of LLMs. That's one thing that's definitely coming.
Right.
The other one, which I'm actually very excited, is superintelligence. Is superintelligence is so one is like broad, like say broad application. So The model can do what an average human can do, like booking a trip, or making a plan, or doing this kind of helping you do assignment, or writing email, writing a code, those kind of thing, which an average human can do, or an average engineer can do, average student can do. But and that's important, right? That's actually very important, the AGI and all these things, like we need that, right? But other direction is super intelligence. Is we have so many unsolved problems in the world, like the treatment to cancer, or many kinds of like problems in engineering, science, and all, finding new avenues for research. Um, there, if we can have a model, right, and that can be as good as a superhuman, right? Say,
Mm.
for example, a person who winning a Nobel Prize, who are definitely rare. If you can um, make a model as strong as them, or to solve some kind of unsolved problems, that is going to be super super critical. And one intermediate step towards that super intelligence is self improvement. I think one critical ability we as humans have is we reflect, right? We reflect what we did yesterday, did last year, last decade, and we improve ourselves every day. You know,
Right.
can model also do that to learn by interaction, to learn to update and improve. So that can be one critical factor in self improvement. And if that works, super intelligence is not too far, because imagine we give a model lots of resources, lots of compute, and give enough time, right? Because models don't need to sleep, they can work,
Right.
and maybe after 6 months, it can discover something interesting which the humans have not done, you know. So I think super intelligence and before that self improvement is going to be critical uh, going forward.
Right. Right. So I mean, yeah, this is fantastic points. Like I have a couple of questions in the same order. So for the first one that you suggested for planning, right? So I remember like I think one of your recent works that came out like in couple of weeks or a couple of weeks back or maybe just a week back is benchmarking large language models on trip planning, right? So like correct me if I'm wrong, like basically in that particular summary you showed that as of now the large language models that we use in the current settings, they don't perform really well on the data set or the benchmarks that you guys developed. And is it fair to say that it because those large language models are not fine tuned on your own preferences, or let's say my personal preference is what do I prefer to do, is that one of the roadblocks for achieving great uh, results on those planning data sets, or is it something more? And that's where the agents come in. Is that correct to say?
Yeah. So, like as you said, that data set is for three kind of tasks. Like trip planning is calendar scheduling, scheduling a calendar between two persons, and also for meeting planning.
Mm.
Basically, you want to meet people, meet friends, and how can you plan for that? So the thing about um, large language models is, as of now, they are not able to do it. But then that doesn't mean they will not be able to do it in future. And now there are two ways to approach it. How do we solve this problem, right? So first of all is going big on inference time, right? Like I just talked about the agent-based system. See, in LLM, in that paper, we gave model one chance to do the task, right?
Mm.
Basically, given a plan, given a question, make a plan and solve it. But maybe we need to give model multiple chances, and that's where the prompt engineering come into picture. Maybe decompose the task into simpler task, you know, and then have an agent that does this simple task well and to finally do a task. And that means, of course, it's going to be more time, more inference calls, so more compute, and but still that is one way, that is agentic approach to do planning, which I think has a lot of potential and can do well. And many people are already doing that. I know many companies, they take these LLMs and they use this as an API and do some prompt engineering and call it a lot of times to do the task. That's one way to solve it, right? The other way um, is equally interesting. It's probably more interesting to me is what can you do in training? Is there something in the architecture? Is there something in the loss function? Is there something in the data? Definitely, there are definitely something in the data that can be fixed easily by creating more data that can give you some boost, But I'm more excited that if there is something even deeper, is instruction tuning the best way to train these models? Is there a better way to get a richer signal from the same data? Is the
Right.
architecture, um, the way attention is designed, um, is it friendly to this kind of planning task? Because this task were recently became popular. They're not there, right? So do we need to revisit the architecture? Do we need to revisit the loss function? Um, I think these are the things. More importantly, close to my heart, do we need to revisit instruction tuning? See this way, right? In the science, right, that the revolution of deep learning and LLM has been driven by one common goal: getting richer signal from the same data, right? The data was there before. I mean, we have more data, more high quality data, but data was there from day one, right? We
Right.
have different kinds of data. Humans exist, internet exists, data exists. You know,
Right.
um, the the way we have the LLMs have evolved and we have more made progress is finding ways to get richer signal from the data. And I gave you one example early in our conversation, what signal machine learning was missing and instruction tuning was able to capture by adding instruction. Or even what signal earlier models were bigram and n-gram models were missing that LSTMs capture better and transformer capture even better, right? So it
Right.
has been always like that. So there's something in that space which is very exciting to me. But like I said, the other line of work, agentic work, is also equally interesting, and we need to invest on that as well.
Right. And maybe one of the overview questions for me that I always ask most of the researchers is, in the last couple of years, I think because industries have been focused on developing these huge models, do you think, because back in 2020 or 2019, I used to think of transfer learning, zero shot learning, few shot learning. These were the hot shot topics, right? If you see it at the conference, they are trying to come up with better, efficient architectures. Nowadays, we mostly focus on scales, like nobody talks on making efficient models. Do you think like scale is over here to stay for a long time, like big models will be um, in the trend for a little bit of research community?
So I'm on the both side, bit of I like the both side of the world. There's a law of comparison, right? I mean, the whole goal of scaling, the people who believe, in scaling, the good goal is that. So this is like the language models you can think of as a mode of compression that compresses waltzed internet text into a some form of weight, right?
Right.
And the goal is, as you it's like as you talk to more people, as you learn, as you interact more with the world, you learn better, right? You compress. Like again, I like to give an analogy.
Right.
Humans learn better as they travel to different places, talk to different people, have diverse experiences. They become better and better human day by day, right?
Right.
And there's no plateau point, right? Like, I mean, today, yes, I mean, tomorrow we'll talk to more researchers, or even quite smarter people, or talk to a different community. You learn something new from them, right? Um, as long as, but that is true as long as you are meeting like new kind of people you have not met, or at least you are meeting people who have just different characteristics than the people you have not met. There
Right.
is no plateau point. You always learn, right?
Right.
That's going to happen because more and more data is going to come, and scaling is always going to improve, right? But then, like in the human analogy, there are two ways. One way is, okay, you meet different people, read different books, you learn from that. you have a you have a learning rate to learn from, but maybe you can learn faster, you know, if you do something smart, right, instead of just focusing on meeting more people, reading more books, or reading, or getting more, focusing on scaling. If you focus on revisiting your old friends or people, but maybe with a different perspective, try to extract more. That's what I was saying about research signals, right?
Right.
So see, I like both. I mean, I do both. I do scaling in part, and as well as still working on ambitious research agendas to see if, like, to question fundamentals, right? If this is the right way to learn. Um, that the way our field has evolved, unfortunately, we follow the trend, and we do that until somebody shows us that, oh, there's a better way. Then everybody jumps into that. To the person who is doing that, there is a lot of credit to show us that there's a different direction to solve problems. So, and even then, right? So see, the scaling is not going to stop, right? Even then, so it's like you just upgraded, like, from elastic to transformer, then transform to something else, or like multitask learning to instruction tuning, instruction tuning to something else. You can still scale, right? Uh,
Right.
but I think, and especially, if I, you know, I were in academia or as a PhD student, I would like to explore that path, and like, what more? Multitask learning, instruction tuning, what next? Then focusing on scaling. Let the other people do that. You know.
Right, right. And there's also a long-lasting debate that's happening in after the outburst of large language models is the fact of understanding reasoning versus retrieval, right? So a lot of people have been proposing that can we use large language models as a math tutor? But like you said, large language models are compressing the knowledge rather than being like intelligent. There's a difference between compression and intelligence, right? So first of all, like, because when you train the model on repetitions, let's say I show it multiple times that 2 plus 2 equals to 4, it doesn't guarantee that the concept of addition is being understood by this large language model. So if I use this for a math tutor, there's no guarantee that it efficiently captures what's the logic behind this particular mathematical function. Do you think, like, first of all, is it fair to say that reasoning is different than retrieval? Can for LLMs be at some point be able to reason? And secondly, do you think concepts such as like math tutors, this is like much more different than just probabilistic retrieval, because I show it the human language in so much different forms, it can predict the next word very accurately. So we as humans understand, yes, large language models capture the knowledge of language. Do you think LLMs can get to a point where it can reason about other logics or other concepts that is different from human language?
Yeah, again, a great point, great question. See, I will tell you, again, with an analogy, right? Say you want to solve a math question, right? A math tutor, right? Do you really think, I mean, the tutor needs to solve a question that do not exist in the internet? I doubt. Or do not exist in the textbook? I doubt. This question gets repeated, right?
Mm.
Um, so, of course, there are some competitions like Olympiads and, some competitive exams where there are some new questions, but many of the times we want the model to be able to do well on existing questions where the search is probably not very accurate. Like, if you search directly in the browser, you may not get a very accurate answer. So that means we need retrieval for sure. That's definitely a good use case, at least for many tutoring system across the globe, that some retrieve the right question. And even though, and not only the repeated question, but also slight variations, right? Say the number is changed, the language is paraphrased, or a question is just a combination of question one and question two, right? So first of all, we need that system. You know, that's a lot of use case. So that we there, and retrieval has the job to do that, and I think it's doing pretty well. in retrieving from the corpora, from its own knowledge, in solving different, tutoring based questions, right?
Right.
Now the reasoning part, right? So reasoning, so it, so it also depends on what you call reasoning, right? If I if I show you three questions on probability and you solve the fourth questions on probability, maybe using the same formula, will you call it reasoning? Because still it's not the same question, right? It's a different question. But because models somehow learn the pattern that this kind of questions required some probability theorems and like formula to solve it, and it does it, right? So if you call that as reasoning, models are pretty well on that, right? And then if you say, or even like across concepts, across like probability and then something else from linear algebra, or say across disciplines, something from biology, something from math, doing composition doing composition of our different concepts is, if you think that's one form of reasoning, model does do that also pretty well at this point. If you know how to use it and if you know how to train it, we can do this kind of task pretty well as well.
Right.
Third thing is if it's really, really new, right? Really, really different. What's the probability of that? Pretty low because the concepts are not new. Concepts are old, right? And people have asked all kinds of questions across competitive exams and Olympiad and all those things. So it might be there somewhere, but let's assume that there is something which is new and just the composition skills are not enough. Then I doubt, you know, if the model can do really well compared to the first two tasks. That's where we need something, something better in terms of training or in terms of like prompt engineering and the inference time, or the way we collect data and all those things. So it all depends on what you call as reasoning.
And because we have been talking about this agents decomposing, and we have seen a lot of researchers who work on symbolic AI between. So like there's not just one model that does tasks from end to end, but they decompose the task at multiple time points, and then the agent or the whole planning system happens. What would you say, like, because a lot of people would say, if I have such a system in place, the model will be inherently able to reason better, right? Because it can explain stuff much more better, what exactly led to that particular chain of thought. Um, what would you say? Like, do you think still large language models, if you train differently or with new techniques, will be able to totally overlap those particular old traditional intelligent algorithms? Or do you think that still has some value?
Um, I would say I would like to take inspiration from those, and use that to we should use that to build some of the next generation of training methods or new areas in LLMs. Now, the future, I am more of like a LLM optimistic guy, you know.
Right.
I think they're like I've seen both sides. I think because see that other side is it's not very user friendly, right? Because humans defining the steps, right? I mean that's the whole point of AI, right? Like to make it easy, right?
Right.
If you see, I mean, why do you like LLM? Why do you like ChatGPT, Gemini? Because you just ask something and it answers, right? You don't have to worry about anything else, right? Makes it
And
very
also
easy.
generalizing, right? Like it can take in your raw inputs rather than having it in a particular structure. It can
Right,
work with raw inputs.
right. It can understand natural language. It can understand, you can, even if you do a typo, it doesn't do a problem. It's not like a program it's going to create an error. It understands free form language. It understands humans do mistakes. It understands humans have different way of expressing things. So you would like it, right? It's very
Right.
more very flexible, right? Imagine your flexible friend who is ready to go anywhere to your road trip versus somebody who is rigid. We always like the flexible person, right? Who's like. So that's where I think. I mean, LLM is again like then what you call that as LLM or something else. The terminology might be different. Might be. because then something else comes, then the name will be changed. But I think this line of work, automating automating learning patterns from data and generalizing and doing well on free-form language, that's critical.
Yeah.
That's going to be there. And it has happened in the history, right? Before this LLMs really took over, there were like many intermediate works, that was using intermediate form of, like you said, those kind of work. So those works will be there, and they are not they are actually helping us to take the next step in LLM, because we get inspired from the result, right? And that helps us to build many of the algorithms and put it in LLM. So they also have a critical role to play, you know. But then eventually, I think it will be more on this side, LLM side of work. And that's going to stay. Yeah.
And for the second part of the podcast, I want to zoom out a little bit from what your research is and also focus more on the other aspects that is out of your niche research topic. So you have been like I have not met a lot of people who had this many number of internships that you did in your research. And typically, if you ask an average researcher, they actually consider industry internships to be kind of distractions from their main core area of research, because typically what you work on in your PhD, there is not a clear mapping to industry product or something like that. But this was not the case for you. Like this was the boom of industry where people were working on large language models. So I want to learn what exactly and how did industry internships help you, because you did a bunch of internships. I think I met you in 2022 when we had this chat and you were jumping from one internship to the other. It was like, maybe correct me if I'm wrong, but it was like a full 12-month period where you were interning at different bunch of companies, different researcher labs. So I want to understand, how did that particular phase help you maybe amplify your research, design your research and make new connections, and how this has been useful, and what kind of tips you would give to PhD researchers to maybe follow a similar trajectory.
Yeah. So, I always have get inspired by this quote that if I have 1 hour to solve a problem, I will take 59 minutes thinking what to solve, and then trying to solve in 1 minute. So knowing what to solve, knowing what to work on is super, super critical, you know. And it comes from experience. I um, spent a lot of time, before, trying to solve some problems that are not very important. And then I learned that, focusing on the right kind of problems is important, right? And now, how do you know what problems are important, right? Because I mean, like, in PhDs, in academia, we read a lot of papers, and I mean, many papers excite us, right? But then the truth is, only a few percent of papers is actually doing the real impactful work, and those are the areas which are important, right?
Yeah.
And how do you know about it? One way is, like, do industry internships, like talk to some industry people, because industry, the models that I mean, they convert to product and people use it. Really, revenue come from. So what kind of problems are important, right? So at least that is the primary goal, to know, like, you know, the pre-trained language model also need to be aligned to user preference to do well. Similarly, PhDs, your PhD, everybody's PhD, need to be aligned well to some kind of useful. I'm not saying to bring revenue or bring profit or like product, but like some kind of useful, impactful output that you can contribute to, right? So knowing that is important, and because often in academia we are driven by curiosity, right? We do curiosity-driven research, but curiosity, when applied in the right problem, becomes impactful. You know, so that is one of the goal. And I did work on industry before, so I know the difference, how it feels before PhD, and that's why I have some perspective, but I want to learn more and to see what kind of problem students are important. That's why I decided to go for internship, and my advisor actually was super helpful. He you know, let me, work with the problems I want to work on. And he helped me go to different places, do the type of work I want to do. So yeah, I mean, that's one thing super critical. And actually also having diverse experience also helps, because you get different perspectives, you meet with different
Right.
people, not like one kind of people, different types of people. Like you said, scaling diversity is critical, you know. So I think that's had I had in mind. I think it helped me a lot
Yeah.
in my journey. Yeah.
Yeah, because even like I have done bunch of industry internships, and one thing that I find very unique about the field of AI is that it has been fueled by both these sectors. Like if you see some of the developments that came out of works that were fueled by industries, like for example transformers, like it came out during the projects bit behind the minds from people in industry, and it has been fueled by some of the novelties that came from academia. So there's always a new point when you actually apply AI models in the real world. There is a bunch of difficulties. So even like when we talk about scale, but scale itself, like I think fuels a lot of inspiration for making better efficient models and those kind of things. And I wonder like what your thoughts are, because if you see like Jan LeCun recently tweeted, right, like if you are a young PhD or researcher in the field of AI, you should not be working on LLMs. He put that in block quotes, which in some level, because I'm not from the LLM phase, like LLM research, so I kind of agree with that. But if you like, you are one of the outliers. If you see like you have been working with industries in academia in some of the other techniques that are related to LLMs, like you're not working on pre-training an LLM, but you are working on techniques that will make these pre-trained LLMs work in the real world. So I wonder what are your thoughts or like on that. Like would you still recommend, like if a young PhD student comes to you and asks Swaroop, like I want to work on LLMs, tell me where do I start, would you what kind of advices you would give to that person?
Great question. This is my favorite question. I'm glad you asked me this question. So, like I said, when you say people want to work on LLMs, I mean, they often think of, okay, reading some a bunch of papers, writing few papers, and graduate and all. That's probably not ideal. I mean, that's fine, but we need to find out how can you really improve these LLMs in doing reasoning, planning, and many of this unsolved problems, and like how what are the capabilities that can empower that. So now, to do that, if you just stick to LLMs, and just use it as an API, and probably you might not have a great success. But then you have to question the fundamentals, right? Like, why do we need to do this autoregressive uh, language modeling, like the next word prediction, word instruction tuning, RLHF? Like, why do we need to do those things, right? So, if you question the fundamentals, don't take things for granted. You have a higher chance of being successful, than just taking things for granted and writing papers, right? Um, I would say that again, like I said, the terminology is ambiguous. Something next, what comes? I would still say it's an LLM. People can call it something else, but I mean, so that's why I would say you still need to know how LLMs work, so that your idea is grounded towards impact, right? So
Right.
transformer, became transformer because it showed that it is better than LSTMs in machine translation, another task, right? So you can have the right tool, you can have the right idea, but you need to show that it's on par with current generation LLMs on different tasks, and better than uh, LLMs on on some tasks. Then only your idea will fly, right? So I mean, when somebody says don't work on LLMs, that doesn't mean that you don't know what's in an LLM, but you try to do, like, you don't take LLM for granted. You do some new methods that outperform LLMs. So knowing the LLM area is going to help you. It's not going to. So I definitely would suggest to learn enough time, like, to understand how LLMs works, what are the strength and weakness, and then build their model, and of course ground it with LLM to really propel, the idea. Yeah.
Right. But a follow-up challenge for most of the students who get started in this field is the chain for understanding the whole sequence of evolution of this process, right? So like going from semantic modeling all the way to LSTMs, then RNNs. Now we have large language models, and even the field of large language models is highly untapped. Like it will take me years for me to understand what's exactly developed out there, what's novel, what's like an actual challenge. So what kind of tips you would give to people who are trying to narrow down the research focus? So it could be industry, like it doesn't have to be just PhD project, but let's say if I want to work on a research topic, how do I go from learning the basics, learning the current standards, and then finding a challenge to work on that has some importance or some impact in the community?
So I would suggest, see, doing some courses, like basic courses help, but I think this area has changed very rapidly. I mean, I can tell you, suggest you some courses to start with. There are a few
Yeah,
courses available publicly, but then reading the right papers is like that's super important to know what's happening and many things. Unfortunately, these days, the publication, I mean, it has become because many of the critical stuff, do not get published these days. So that's where the challenge come from. So there are three challenges. First of all, doing the basics. I think there's no problem there. Doing some courses, reading some books, one person can really do that well, right? But that's like sort of like a theoretical knowledge, or sort of the knowledge which is helpful 3 years back, but not now, right? Because the
right,
field has evolved. The second is reading the right papers. There you need a guidance, and Twitter helps. Twitter actually, if you know to follow the right people, um, you know, some of the high profile people, from their thoughts and papers, you can get some insights. That is second. But even
right,
then, it's incomplete because last few years, right? Especially after like ChatGPT and the recent development, many of the critical stuff, because the papers have now turned into tech report, and where the many details are missing, right? So that's where the challenge come from. Like how do you know the what's the reality, or how really the things work? And there I would suggest, like, meeting people, trying to see if you can go for internship, or like work with industry for some time. That's where some of the real skills and real knowledge can come from. And then you can, once you know that, you can do what you want to do, and nobody can stop you. I think the
right,
first two phases are relatively easy. The third phase is what's going to be taking some time. Like they say, right? Unless you make your hand dirty, you don't learn, right? So you have to be in the space to learn, and yeah, to really know what to do next. Yeah.
right. And also one thing that I tap into, because most of the audience that I have are like researchers who want to either transition to academia, or sorry, transition to industry. They are either in industry or they are either in academia. And one thing that I wanted to learn. So you have done a bunch of internships in the industry, uh, in labs which were sitting at the intersection, right? So there were labs where they have collaborations with industry, and also they have some collaborations with university. What kind of advice you would give? Because there's a fair transition. There is a big chunk of demand for people who can do research and can also be in the industry, but there are also subtle skills that a person you would think that should learn, apart from just being a great researcher who can do great coding or who can do great writing. I think there are other skills that maybe researchers are in need of, because typically on an average you don't see researchers much in industry right now. Most of them stick to academia or other kind of roles. So what kind of advice you would give to your past self, that you think that if you had those skills, your transition to being in the industry would have make it much more better? What kind of other skills you think people should learn while they're in academia before they make the jump to industry?
So, I mean, first of all, I would like to, mention one thing, that there are actually a pretty good number of researchers in industry as well. And many of this, I think it goes unnoticed. But I think this all the success of ChatGPT and Gemini and all these large language models, a lot of credit has to go to researchers who built the really the next generation pipeline to empower this. It's just not software engineering. Software engineering is important, but research is, at least in LLM, it's what has guided the wave. So that's one. And now regarding, but academia also has researchers. So the researchers are there both places, right? Regarding the advice, I think one thing is stubbornness, like how to stay stubborn and question even the very fundamental things which might appear stupid, but you know I think that's super important. Questioning everything is super important. And often intuitions, like borrowing ideas from human observations. Like with the beginning, we talked about how this a local Indian sport that inspired me in my research, right? So those kind of like trying to analyze, from many of these things are nature driven, right? We observe from nature, we observe from a surrounding, and then try to make something out of it, right? So those kind of critical thinking, and that is important. And also short term versus long term, right? So when you are in PhD, right, you are always, you might feel are under a pressure because your peers are publishing and you have to publish, right? You have to
Right.
publish every 6 months, every year, or every few months, whatever, the frequency, right? And then you know what, it's you've optimized for some short-term goals, short-term hacks. Oh, maybe I should create something quick, just change the parameters slightly and get some good results and publish. But that's do more harm. I mean, you need some of those paper the early to get into the cycle of publishing and all, but that's because that becomes an habit. And once it becomes an habit, it becomes very difficult to get rid of it, you know. So I think it's super important to gain those skills, because you'll not probably not get that time later on. I think having the right habit of questioning everything, staying stubborn, and um, try to optimize for uh, at least slightly more medium term or long term goals over short term. And I mean that also requires a lot of patience, right? Because then if you see, if you try to compare among your peers, I mean then you might lose track, right? So I think toward having a bit more patience, and yeah, questioning everything and giving yourself more time. And also I think one very good point I want to mention, glad that you asked this question, is reading less. It's
Oh,
controversial, but let me tell you this. Let me restate it. Reading less is important if you want to do great in research. Because it's a human tendency. If you read more, you get biased, right? You know,
right.
have you observed this? Like, if you met a friend who told you some words, you might tell the same words, next day, next week. It just biases us, right? The behavior.
Right.
So, and especially when you are learning, you are getting biased. The learning is also learning from a specific person, specific textbook, specific paper biases you. The authors or the narrators' observation, and that in their perspective of things, which is which has worked, which is successful. That's why we're learning, but may not be the best way, right? Like LSTMs were successful, right? But
Right.
transformers came, right? So I think knowing, like reading. So what some people do that mistake is, read a lot, make a habit of like spending couple of hours every day to read. I don't recommend that,
Mm.
because trust me, try this. You read like 5 papers. If I ask you questions, likely the idea you are going to tell is a composition, if not directly from them, maybe
Right.
some kind of combination, and that's harmful because that will give you one paper, right? You can go to a conference, enjoy, and you can get some citations, but that is not going to create a breakthrough. That is not going to make your name, right?
Yeah.
Uh, so I think read only essential stuff and try to focus more on analyzing and thinking, introspection, reflection, those kind of stuff. That is super important. Read less. That is super important.
Yeah, yeah, that's a fair point. Like now, because I look back, because when I started in my PhD, I used to be that opposite person. What you said, I was trying to read more number of papers, more in depth, and this was the phase where I didn't know how to read a research paper. Right, so there are a bunch of things, and it's like a highly condensed version of a big research topic that people normally try to condense in. And one thing that at least I think after 4 years I'm getting good at is like if you give me a new problem, I'll still read a bunch of papers, but now it's more like skim reading. I'll be able to understand if this paper is, I wouldn't say it's good or bad, but if it's relevant for my particular research direction or not in maybe few minutes, and then I'll maybe shortlist to maybe 3 or 4 papers that I'll read in really depth. And this is the kind of papers I'll even read those references that the person has cited. So now it's just selecting, it's like retrieving more number of papers then, but then shortlisting it to just couple of papers where you read into the depth of what kind of mathematics they have used, what is the background of problem that they are trying to target, what is the proposed architecture, and again what is the most important thing is the limitations and discussion section for that particular paper. So yeah, I agree, it's like getting influence. It's similar to what we talked about the instruction data quality, right? It's similar to that. It's real world instruction tuning of yourself as a researcher. And if you select bad points, then the model is very sensitive to learning the wrong things. So yeah, that's a fair point.
See, the model training and human training are not very different, you know.
Yeah, yeah, that's true. And
And
one thing, sorry, go ahead.
I just want to add one more point. It's not just about paper reading. When I say read less, it also translates to other experiences. You know, say, you know, like you're working on a project, right? I mean, some other people are also working on it, right? I'm giving you a hypothetical situation, right? So some other people might get some results, right? Like, and that might be exciting to you, right? But then if you pay too much attention to what others are doing, what it's not just papers, even the approaches, what the areas others are working on, how they're spending time, that is also harmful, right? So it's
Yeah,
like detach. I think detach is the right keyword if you want to do, because more and more you pay attention, pay emphasis to the areas people are working on and the methods people are developing and their thought process, more and more again you always be in that line, but you have to detach because you are made to do something big. So that's why this detachment is actually super essential to do well. Yeah.
yeah, fair enough. And one of the thing, you also posted a poll sometime back on Twitter that most of the researchers often find themselves going into the rabbit hole, right? So we, as PhD students, like you are a young graduate, so maybe you can relate to this thing. Is we try to optimize for the wrong metrics that we don't know, because at the end we want a metric to chase, right? What is the kind of metric we normally look for? Number of papers, number of citations, number of publications that I want to get into. What kind of tips do you think you will give to researchers? Because at the end, like I, even most of us will say that okay, don't optimize for number of papers, don't optimize for number of citations, but at the end if my goal is to go to the industry, and it's very hard to track if I'm making genuine progress towards the novelty of AI, right? Because every other paper you read on archive says like a novel model to do XYZ, a novel technique to do ABC. So, how do you define a metric that actually works, and maybe a metric that worked for you to understand if you're making actual progress towards your um, dissertation or in general research? What kind of metrics did work out for you?
You know, mm, I would say appreciation or citation from some of the people top in the field. One of those is actually much more powerful than 10,000 citation or like, you know, some so there you it's like I'll tell you my personal satisfaction and like how I feel and like as a PhD student. So if your work is good, right? I think see citation number of papers is a byproduct, right, of you doing good work. It's not a goal because if you optimize for that, it's going to haunt you. You know,
Right.
it's um having you know. doing quality research, and then you will see, right? You don't have to like, actually, as a PhD student, as a I'm talking about like few years back, like 2021, right? The amount of email I got after that instruction tuning paper, the first instruction tuning paper, it is pretty overwhelming. People often appreciate it by emails, and some of the people who you really look forward to, it's like the top in
Right.
the field, and that actually, give you pleasure that okay, your work is being recognized and people understand, people feel the similar sentiment that this is important. Think that is more valuable. And remember, connections, humans, the networking connections, that is important, right? Because um you I mean, the metrics are for the outside people to judge, but for internal people, they have their own world, right? They know they did the researchers accordingly. So that was like very exciting point for me, that people are interested in a paper, they want to talk to me, you know, and that really helped me. And if you see, that empowered my citations, right? And the number of papers. But I'm not saying it's a byproduct, it's not a it's not the goal, right?
Right.
So now for people, for students, right, the who are doing PhDs and all those things, one thing is, if you have to convince that your work is novel, your work is not novel, right? Or
Mm.
if you have to use the word novel in the paper, you have to think twice. Probably it's not.
The work has to speak for itself.
The
Like
work
people
has to
should
speak,
find it novel.
right? Exactly. That's the thing. The work has to speak for itself. And if you do the right baselines and do a fair evaluation and you compare, I think the recognition will come to you, and it may not come to you directly in the form of citation or all those things, but it'll come to you, you know, like I remember that year, I think I went to a conference. It's my first conference attending in person in NLP ACL 2022. Next year, I think 2021, I wrote the paper. 2022, I went to the conference. I was actually very surprised. Like some of the people I really look forward to, and they met me at the conference and they said hi, and they said they read my paper and it's really good. Like some of them emailed me back beforehand. Some of them told me that directly at the conference, and they know me by, okay, you are the natural instruction guy. So that is and a different level of satisfaction we get as humans or as a PhD students, that we appreciate. That is like one level, right? um, then the other thing is, um, if you if if you also feel like the type of work you did is being used by a lot of popular works, in the as a follow-up work, right? I mean, that's also a form of citation, right? But it's not general
Right.
citation. It's a power citation, in the sense that your work really propelled it, or
Right.
your work led to a product like ChatGPT or something which is like change the world, right? I
Hmm.
think that's rare. I mean, I'm not saying it happens every day. That's rare. But, I would, if I go back to in the same position I was in, I'll probably might take a different route, but the goal will be the same. We do PhD once, right? why to do for why to optimize for short-term hacks, like, always do for long term. If we fail, the failure should be intense enough for us to understand it's failed, we have failed, right? If we do
Yeah.
short-term things, so I would actually take the same path again, the same goal. The method might be different, to target, like maybe target. So we targeted multitask learning and got instruction tuning. Now somebody else target instruction tuning, get something else, right? Or
Right.
target auto-regressive nature, target something basic and fundamental, and do a thorough evaluation. So that's, I think, one high quality. So basically, again, I keep telling this to everybody, the young people I talk to. When you go to conference, when you talk to somebody, they'll remember you for one or two paper, like two or three paper, couple of papers, right? Not 50 or
Yeah.
60 papers you wrote, right? So I think so knowing that is important, and don't get disturbed even you see other people publishing 10 papers.
Yeah, but I think with that, I think it concludes our podcast. These are the kind of questions I had for for you for this particular podcast. Overall, I think we talked more about the optimistic sides of LLMs. I think I can do a separate whole podcast with understanding the limitations of LLMs, which is very fair to talk about because at the end, like you said, it's a knife, it's a new tool that is being thrown out into the industry. So it obviously has some limitations. Um, a lot of people have the misconception of understanding LLMs are the next biggest intelligent thing. It's not. At the end, it's a tool. It needs to come with instructions and documentation how to use it and where not to use it. I hope we can do a podcast follow up to this one if that's of interest to audience. But we also talked about some of the works that I personally wanted to learn from you is instruction tuning, which is kind of most of the people who might not know from this conversation, but instruction tuning is one of the technique ChatGPT was trained on. So it's some way or the other it's fueling most of the large language models. So I hope it's useful for people to understand how did you come up to this topic, how what you are working on, what Google is working on, and how you have evolved as a researcher. I'll be leaving your link of Twitter because I think some of your tweets are very useful. You also condense them. So it's like a paper, but not a paper kind of tweets. I think I read the tweet that you posted recently on trip planning and other use cases of LLMs. So people will find that useful. But apart from that, thanks a lot for being here. Hopefully, we'll get to meet soon. So yeah, thanks for being on the podcast.
Thank you, Jay. Really nice talking to you.